Our automated test tool is a web application that generates the test data and execute tests for the assignment 3 in CSCI314 last semester. The system that we're testing here is the shortest path problem. The program will read from standard in to integers the end vertices and end edges, which are the number of vertices and edges in the graph, following by the information about vertices and edges of that graph, as well as the start and go vertices for which the paths are required. The program is a C++ program. We'll need to read in this information and generate the shortest and second shortest path between the start and the go vertex. Our application will generate the test data, execute those test cases, and compare the output with the expected output.
In TDD, we write new tests for new functionality. The application of TDD and this tool is that it automatically generates tests for new features just by ticking a new option and running the test. Our first video of the code will handle the test cases of no path exists, which means the input graph has no path from start to goal. You can see that the new test group has been generated into the table on the left. Now we are going to generate test cases for the shortest path only. This new test case group will contain an input graph that contains only one path from start to goal. You can see that the new test group all failed.
For the first iteration, we can see here that I have not implemented the shortest path algorithm. Therefore, I will need to implement the algorithm and call it in the main function. If the shortest path is not found, the program will print that there is no path from start to the goal per vertex. Otherwise, it will print the shortest path.
As a result of refactoring the first version, our second version can pass both no path exists and shortest path only test group. Now try to pass the test for both shortest and second shortest path group with that same code. However, we can see that those test cases have failed.
For the second iteration, the program fails the test cases because I have not implemented the function to find the second shortest path, so I will need to implement that function and call it from the main.
The third refactoring will allow the test for both shortest and second shortest path to pass. As we can see, all these tests have now passed. We will now check to see if it can pass the fourth test case. We can see here these tests have failed.
For the third iteration, the program fails the test cases because it did not check for input validity. Therefore, I will need to implement input validations inside the input reading process. We can see here that the main function has become a lot longer and more complex than in the beginning because we have added more functionalities to it. So I think I should divide the main function into smaller functions, including function read input to read and check the input from standard int, the function find and print shortest path to find and print the shortest path, and function find and print second shortest path to find and print the second shortest path. This refactoring makes the program looks a lot clearer overall, and it will be easier to debug in the future.
We will now upload the fourth final refracted version. This final version has passed all 4 test cases.
When user press Run Test button, the program will automatically generate the test case groups based on which are chosen on these checkboxes. For each test, we have the test type, the input size, the input, and the expected output. And the logic behind the test case generation of our program is, for the input, we have some function to automatically generate a graph that can meet some specified condition. For example, if we want to generate a test case for the both shortest and the second shortest path, which is this one, we will create a graph that has 2 or more paths between the start and the goal. So there should be a shortest and a second shortest path. For the input error, we will have a distance between two random nodes that is negative, so that is invalid. So the program will return invalid input. The next thing is the test size. So if the number of vertices is between 3 and 10, it's going to be a small test. And if that number is between 150, it would be a medium test. And if the numbers is 150 and 200, it's going to be a large test.
In order to run the program, the user would choose a text file or .cpp file that contains the code written in C++, and it's gonna load the code in this code editor. The user can do some final editing here. They're gonna choose the test generation options. And like here, click on Run Test, and the status of the test gonna be shown in this log panel. After finish running, the user can click on individual test cases to see the test result, the input, output, and expected outputs. In order to check the correctness and appropriateness of the test results or our test oracle, we are using a sample correct program that generate the correct outputs in order to test the system. This program produces the correct algorithm and correct output, which has been tested and got the full mark in CSIT314 assignment last semester. We're gonna run this program using the test input, and the output produced by this program is the expected output in this system. The result produced by the tested programs will be compared to the expected output, and if the two output match, then it means that the test case is successful, otherwise gonna fail. For example, in this case, the two outputs do not match, therefore this is a failed test case. Besides that, when the program is not executable, for example, in this case, when I submit a program that cannot be executed, like in here, like in this case, it throws a runtime error. So the output will become runtime errors to show the user that there's an error while compiling and running this code. And therefore, the result of this test will be fail as well.